The air war over Europe and North Africa in the early years was dominated by the German fighters, specifically the deadly Messerschmitt Bf 109 and the formidable Focke-Wulf W190. These aircraft were undeniable engineering masterpieces, meticulously built around the core philosophy of speed, high climb rate, and rapid acceleration. They benefited significantly from being introduced earlier in the war, often allowing them to dictate the terms of any engagement. In a high-speed attack or a steep climbing maneuver, the Allied pilots, flying fighters like the early Spitfires, P-42s, or even the initial P-51 variants, were frequently at a tactical disadvantage, forced into a defensive, reactive posture rather than seizing the initiative. The fundamental problem was that the Axis planes could often outrun and outclimb the Allied aircraft, meaning survival often hinged on avoiding the fight the Germans wanted to wage, rather than winning it outright. This imbalance created a harsh, tactical reality for the Allied air forces. If you couldn't match the enemy's speed or sustained maneuverability, you couldn't dictate the fight, and survival became a constant struggle. Allied pilots learned quickly that entering into a prolonged, twisting, low-speed dogfight with a German expert was a near-death sentence. The superior power-to-weight ratio of the German aircraft allowed them to pull tighter sustained turns and climb away faster, leaving the Allied planes dangerously exposed to attack from the rear. The weakness lay not just in engine horsepower, but in the inherent aerodynamic superiority of the Luftwaffe's fastest interceptors, forcing the U.S. and RAF into a cautious, energy-conserving style of fighting that often meant sacrificing the kill. The true fundamental limitation that crippled the Allied pilots' combat effectiveness wasn't their aircraft's wingspan or engine. It was a biological constraint, the pilot's own human body. In a high-speed aerial engagement, a pilot's survival depended entirely on executing instantaneous, sharp, high-rate turns necessary to get the critical firing solution on the enemy. Executing such sharp maneuvers, however, generated intense G-force, gravity force, which is the force of acceleration, multiplying the pilot's effective body weight several times over. While the aircraft structure could mechanically endure these incredible stresses, the wings wouldn't snap off. The complex internal plumbing of the pilot's circulatory system simply could not cope with the rapid fluid displacement. When the pilot pulled back hard on the stick to execute a turn, the rapid acceleration instantly forced blood, which is non-compressible, down from the pilot's head towards their lower extremities. The immediate physiological result was a terrifying sequence of symptoms. The pilot's vision would dim, known as a gray out, then fade entirely into a frightening blackout, and if the high Gs were sustained for just a few seconds longer, the pilot would lose consciousness completely, a condition known as G-LOC, G-force-induced loss of consciousness. This physical vulnerability was the silent, invisible killer that handicapped every Allied pilot in a close-quarters dogfight, rendering them momentarily helpless at the moment they needed maximum control and focus. This unavoidable biological barrier imposed a severe and crippling strategic restriction on all Allied pilots. To prevent instant incapacitation and the certain loss of their aircraft, pilots were rigorously trained and universally forced to limit their combat maneuvers. They were commanded to pull out of high G turns and dives before the force exceeded a certain predefined human threshold, typically around 5 Gs. The moment the telltale constriction of vision began, the pilot had no choice but to immediately ease the pressure on the stick, sacrificing the speed and altitude they had fought hard to gain, and giving up the vital tactical advantage to the enemy. This requirement to break off the maneuver was a strategic disadvantage that the German pilots could consistently rely upon. The Blackout Line, that invisible ceiling of G-force that limited the pilot's endurance, meant that even if an Allied fighter had the mechanical potential to pull a slightly tighter, more aggressive turn than a German plane, the pilot's own body would fail first, forcing them to disengage. The German pilots, keenly aware of this fundamental human limitation, often deliberately used repeated, sustained high-G maneuvers in their combat patterns, specifically to wear down and exhaust the Allied pilots' G tolerance, forcing them to break off combat, flee, and cede the tactical advantage. The war had become less about pure aerodynamics and much more about the inherent, finite endurance of the human circulatory system. Key to solving this critical strategic disadvantage came not from traditional aeronautical engineering, which was focused on bigger engines and lighter airframes, but from an unconventional physiologist named Dr. Frank Cotton, representing the genius engineer in our narrative. Dr. Cotton realized that the problem was fundamentally hydraulic, not mechanical or aerodynamic. The plane was perfectly fine pulling 7 Gs. The pilot's fluid system was simply failing. His radical insight was straightforward. If the G-force was relentlessly pushing the pilot's blood out of the brain, the only true solution was to apply an equal and opposite external pressure to physically keep the blood where it belonged. His idea, which was initially dismissed as utterly outlandish and almost ridiculous by the conservative military establishment, was shockingly simple. Mechanically and physically squeeze the lower half of the pilot's body during the high-G maneuver. This would require no change whatsoever to the plane's structure, engine, or aerodynamic profile. It was an external, physical trick designed solely to manipulate internal blood pressure. The project was initially met with intense skepticism and outright ridicule. But Cotton was convinced that his simple hydraulic principle, using externally inflated bladders to compensate for internal fluid displacement, could be the single, defining key to shattering the G-force barrier and transforming the human pilot into a superior, more enduring fighting machine. Dr. Cotton's unorthodox hydraulic solution materialized as the G-suit, a piece of equipment that looked more like absurd deep-sea diving gear than military apparel. The suit consisted of thick, heavy canvas trousers sewn with a series of reinforced, interconnected rubber bladders strategically placed over the pilot's abdomen, thighs, and calves. The sheer bulkiness and bizarre appearance of this gear were immediately off-putting to the seasoned fighter pilots accustomed to light functional flight gear. Attached to the suit were hoses that connected directly to a specialized valve located near the aircraft's control stick, designed to harvest the very enemy they were fighting: air pressure generated by G-force. The mechanism was elegantly simple yet completely unprecedented. When the pilot initiated a high-G turn, the G-force itself would activate the valve, instantly diverting air pressure into the suit's rubber bladders. These bladders would rapidly inflate, tightening around the pilot's lower body and effectively creating an external tourniquet. This forced physical compression worked against the centrifugal force, preventing the critical mass of blood from rushing away from the pilot's head and eyes. It was a purely physiological workaround, a ridiculous hydraulic trick designed to temporarily overcome the natural limitations of the human circulatory system. The initial reception of the G-suit was a mixture of intense skepticism, open ridicule, and outright resistance from the fighting pilots and much of the established high command. The pilots mocked the bulky, strange-looking gear, often calling it rubber trousers or a fancy girdle. They viewed the suit as cumbersome, unnecessary, and even potentially distracting in a high-stress dogfight, arguing that the focus should remain on developing better engines or installing heavier guns, not on wearing awkward plumbing. To a pilot whose identity was wrapped in speed and streamlined efficiency, wearing a cumbersome, inflated suit felt like an insult to their rugged professionalism. Commanders were also hesitant to adopt the suit widely. It was unproven, added weight and complexity, and seemed like a bizarre solution to a problem that many believed should be solved with superior pilot training or simply avoiding aggressive maneuvers. Furthermore, The G-suit was completely unheard of by the enemy. The idea of introducing such a strange, untested piece of equipment into the middle of a life-or-death aerial campaign was seen as an unnecessary complication. The rubber suit remained on the periphery, a subject of jokes rather than a serious piece of tactical equipment, until desperation and necessity forced a real trial. The critical turning point came during a high-stakes demonstration designed to either validate Dr. Cotton's claims or forever relegate the suit to the Museum of Strange Ideas. A veteran test pilot, strapped into an Allied fighter and wearing the full rubber suit assembly, took to the skies to face the G-force barrier head-on. As the pilot pushed the stick hard into the corner, executing a tight, sustained maneuver far exceeding the normal 5G blackout line, the rubber bladders instantly inflated with a sharp, noticeable squeeze, gripping the pilot's legs and torso with immense force. The sensation was profoundly uncomfortable, but the physiological effect was instantaneous and shocking. The pilot continued to sustain the aggressive turn, pushing the aircraft past 6Gs and then 7Gs territory that should have rendered him immediately unconscious. Yet, through the compression, the pilot maintained complete visual acuity and cognitive function. The suit had successfully counteracted the blood pooling, keeping the necessary oxygen flowing to the brain. The test was a resounding, irrefutable success. The pilot landed with the triumphant, unprecedented confirmation that the human G-limit was not fixed. It could be artificially broken by a simple application of pressure. The success of the G-suit moved the goalposts of aerial combat forever. Pilots wearing the device could now reliably sustain maneuvers up to 8 Gs and even 9 Gs, an endurance level previously deemed fatal. This meant the human limitation that had handicapped Allied pilots throughout the early war was effectively neutralized. The simple act of compressing the pilot's lower body allowed the aircraft to perform to the absolute limit of its structural capability rather than the limit of the pilot's physiology. The Blackout Line had been shattered not by a more powerful engine or a lighter airframe, but by a pressurized canvas trouser. This breakthrough translated immediately into an overwhelming tactical advantage. U.S. pilots could now engage in sustained, tighter turning battles than their German counterparts. While the German pilots still benefited from their fast, light airframes, they were instantly incapacitated and forced to disengage the moment they tried to match the endurance of a G-suit-equipped Allied flyer. The enemy was still fighting the plane, but the Allied pilots were fighting with a newly engineered, superior version of the human body, turning their former disadvantage into a hidden biological edge. The true impact of the G-suit was felt immediately and decisively in the brutal crucible of close-quarters combat. When a German fighter pilot, confident in his aircraft's superior turn rate, forced an American plane into a tight, sustained turning battle, the expected outcome, the American pilot blacking out first, never materialized. Pilots wearing the G-suit could simply outpull and outsustain every single German fighter. The German pilots, constrained by their own bodies, would soon find their vision grayed out and their consciousness fading, forcing them to violently break off the engagement. This biological disparity meant that U.S. pilots could hold the turn tighter and longer, easily maneuvering onto the German's tail in moments. The tactical advantage was overwhelming and seemingly inexplicable to the enemy. A P-51, which was structurally capable of pulling high Gs, but limited by the pilot, could now execute turns that defied previous combat logic. The American pilot could safely push the stick into the corner, enduring the punishing forces that would leave the German pilot completely incapacitated. This simple piece of plumbing, the rubber suit, transformed the dynamics of the dogfight from a contest of speed and climb into a battle of human endurance. A fight the Germans were guaranteed to lose because they lacked the hidden hydraulic aid. The G-suit became the silent, hidden weapon that decisively tipped the balance of the air war in the Allies' favor, especially in the brutal, long-distance escort missions where survival often hinged on a single maneuver. Because the suit worked automatically, inflating only when the G-force was applied, the German High Command remained completely unaware of its existence and its true tactical impact for months. They saw their elite pilots, flying superior aircraft, being consistently outmaneuvered and defeated in prolonged turning battles, the shock they couldn't explain. The simplest and most ridiculous solution was the one they never considered. The ability to sustain high G turns allowed Allied pilots to escape previously inescapable firing solutions, aggressively close on retreating enemies, and, most crucially, dominate the skies in the critical high-altitude engagements. The engineer's trick provided the non-mechanical superiority that the Allies desperately needed, transforming their pilots into G-force titans whose physical endurance far exceeded any pilot operating under normal gravity. The victories piled up, often credited to better training or more aggressive tactics, but the secret truth lay in the simple, pressurized fabric squeezing the pilot's legs. The ingenuity of one engineer, who looked beyond the engine and recognized the limitations of the human body, resulted in one of the most cost-effective and revolutionary pieces of equipment of the entire war. The G-suit, the ridiculed rubber trousers, did more than just save lives. It fundamentally redefined the limits of aerial combat. It allowed U.S. pilots to achieve tactical superiority through pure, sustained maneuverability, an edge that German pilots, constrained by their physiology, simply could not replicate or counter. The suit became standard issue, permanently integrated into the pilot's gear, ensuring that from that point forward, the advantage in the dogfight belonged not to the fastest plane, but to the pilot with the superior circulatory protection. The legacy of the G-suit is profound. It demonstrated that biological engineering could provide a far greater combat edge than conventional mechanical upgrades. It enabled the Allies to win prolonged, exhausting dogfights through superior endurance, helping secure the critical air superiority needed for the final assault on the Axis powers. The ridiculous rubber trick didn't just save pilots from blacking out. It became the hidden key to winning the skies over Europe, transforming the Allied pilot into an unyielding force that could outturn every German fighter